Thank you. Thank you, Shubham.
Thanks. Yeah, please, please.
Yeah. Um, team, I have shared my screen. Hope you are able to see it. So, yeah, again, welcome to the day two, session two for Prometheus deep dive. Um, okay, so yesterday, as we have set up the our our payment app, and we have done couple of configurations on Docker desktop. I hope it is working for everyone. Like if you have any issues or if you are facing any issues, so feel free to raise it. But yeah, hope it is working for everyone. So that now, once we start working on the deep dive, starting into like looking into the queries, and when we start building the Prometheus and Grafana queries, I hope everyone would be on the same page when we start implementing the SLOs. Clear, guys?
Yes, Santosh.
Okay. So all right. So I would like to start with the yesterday, whatever the files or the details, lab sessions that I have shared. Okay. So before we get into the exact lab session, let's look into the files that we have configured and how they are connected to, like, each service, how it is configuring. We have configured them and how are they interacting with each other. Once these file configurations are fine, everyone is okay with that, then we will proceed with the visualization part. Okay. So okay, so let me open. If you see, like, you will also having the same folder structure in the SRE lab. We have three directories: Grafana, Payment App, and Prometheus. And we have one YAML file, Docker Compose YAML file. Okay. And I hope everyone is having the same folder structure. And if you open the Docker Compose YAML file, let's go check the first docker.yaml file, what we have done here. Okay, so this is nothing but we are starting the containers, like when we yesterday started with the build process, right? And it has brought up the containers, correct? So what exactly we are doing here is, if you see this uh, Prometheus app. Okay, so what we have done yesterday, we have started one Prometheus server. Okay, we have started a payment app. So let's say that is nothing but exporting the logs. Okay, so we have started one payment app. Okay, we have started one Grafana instance, and all this setup we have started as a part of Docker Composer. So if you see in this YAML file, what we have done here is, see, we are fetching the image, Prometheus image, and we have given the name SRE Prometheus here. Okay, and we have created one Grafana instance, Grafana container we have created. We have created one node exporter. Okay, so if you see in this diagram, we have this exporter, correct? So this is nothing but the node exporter. So far, uh, we are not fetching any live production related information. So at this time, like, we can ignore this exporter part. But what we have done instead, we have created one app, right? We have created a payment app, which is creating a traffic for us, and it is giving us the values, right, for payment history endpoint. So we have created one container for that as well, the app, like payment app, and we have opened the port 8080. And if you see here, uh, if you see yesterday, we are able to open the Prometheus Grafana and the ports that we have configured. So we are exposing this port, and so that we are able to open this port from our system. Okay. Now, when you check the Prometheus directory here, we have a couple of directories, like Prometheus, Prometheus.yaml file, rules.yaml file, and script example. So okay, so so on production like environment, how this script exactly works. So I will show you that part as well. But let's look into the Prometheus YAML file. Okay, so if you check the Prometheus YAML file, in this one, the script interval we have configured is 15 seconds. So when we correlate that with our example here, so it's the same. every 15 seconds, Prometheus server is scraping. That means it is pulling the information from the target endpoints. Whatever the target endpoints we have set up, from here the Prometheus server is pulling the information in every 15 seconds. Okay, and it is that is the retrieval time. Okay, and it is storing into the node that is not on the time series based database. Okay, so if you see here, every 15 seconds we have configured. Now this is rules file. Okay, we will go deep dive into the rules file as well. But okay, so this rules file usually we use it when we have to set up a kind of rule based. Okay, so if you see the rules we have configured, this is nothing but the alerting. This is, let's say we have configured, like we have defined our SLO that my payment application should be up by 99.99%, isn't it? So if I notice error rate, if it is getting increased more than 99.9%, that is, if it is more than 0.1%, I should get an alert. Okay, so your error budget is burning fast. So as we discussed in our last week's session, what we have to achieve from this visualization, that how my error budgets are working and what is the overall trend. I need to analyze that. If I notice that if the overall error budget is more than 0.1 second, I need to be alerted. My team should get an alert. So how that will be sent, alert that will be triggered, we will look into that part as well. From the Grafana, we can set up that part. But at the Prometheus side, also we can configure the alert. And
Sorry
if
to
you see,
interrupt, Santosh. It's like how you like to know, like it is a 0.1 second or something. How on what basis we are taking it?
correct. So see this 0.1 second, 0.0 seconds that we are calculating, right? So this is nothing but we are having this expression. Okay. So I believe we have discussed this as well. So see the overall transaction rate, overall request of failure rate. Now, if you see in this expression, what we are doing, we are checking the endpoint for the payment. For pay endpoint, we are checking how many 5xx I have in the 5 minutes of interval, and we are dividing that with the overall request rate. If my overall request rate compared to the failure rate, if it is more than that, then it is nothing but my error rate is increasing.
Okay, got it.
Yeah, so I'm comparing with that. So this is the expression, and this is the same expression we will be using while setting up the alert in Grafana. Okay, so if I notice that my error rate, if my 5xx errors are increasing, that means if it is exceeding 0.01%, then it should fire an alert. Similarly, as we discussed yesterday regarding the latency part, that we are trying to monitor the P99 latency in your application, correct? So let's say my out of 100, like let's say I'm monitoring all my applications, and out of them, like let's say the overall requests are above 99%, above below 300 milliseconds. And if I notice that if my overall average of the 99 requests is above 300 milliseconds, then I should receive an alert. So similarly, we have this histogram PromQL that is defined by this Prometheus, where we are usually check by the latency. And if you see the payment request per seconds, so what we are exactly doing here is we are checking the overall payment request by seconds here, and in the interval of 5 minutes, especially for the payments app. And if we notice that if the overall latency of the payment API, if it is if it is more than 300 seconds, more than 300 milliseconds, then it should fire an latency alert. Coming to the infra part, okay, so that we have to configure with the node exporter. Okay, so that will fetch the metrics like CPU, memory, disk space utilization, right? So in our application, this payment app, we are just mostly focusing on the request response error rate latency part. Okay, as it is not capturing the infra level configuration, since it required a proper VMs and all in place. So as of now, we are we are not considering the scraping the target for the the overall metrics for the infrastructure part. Whereas we will today look into the part of payment SLO and how to configure the alerts for our application. So far, hope we are up to the point here, guys. If you have any doubts or any queries with this file, please let me know.
Can we see this configuration in the UI part? In the UI?
Yes, I will once we discuss about this, we will move on to the UI part as well. Yeah.
I don't know what I'm asking. So we are in my office, in my project, we have already configured everything. So I cannot see this YAML part. So in the UI, can I see this YAML file? Like in Kubernetes, we can see the YAML file, right? Like that.
Yes, we can see that. We can. The rules part also we can see that in the Grafana YAML.
Okay, got it.
Yeah. All these configurations, there are like you can change it from the backend as well as from the UI as well. Okay.
Yes, Santosh.
Yeah.
All these formulas that we can see, like sum, rate, payment
Yes.
request, is there any standardization documentation for this? I mean,
Yes, we have this. So whatever the queries that I'm showing here, right? It is the PromQL standard queries only.
Okay.
So it is defined by the PromQL only. Okay.
Yeah,
So
but how you will know that we have to use, the rate of payment duration only, and of
Okay.
second or per minute or whatever thing, how you will try to identify it.
So so these parameters are based out of like how you are So the total request, right? So in your application, in your log format, so this is something that we need to see how your application is being. So you mean to see the seconds packet latency?
Like overall thing, like how you are trying to take that, particularly with right. And I understand, like for initial 500x, you're based on your request, you're trying to take it out.
Yeah.
Okay, but when it comes to like your what we like P90, P99 and P95, like to check the difference and all the thing in the time thing, how you are able to take that, like exactly why we have to take that particular parameter only.
Okay. See, for P95 or P99, it is purely depend upon the priority of your the severity of your application. Okay. So see, even for let's say for the payment type only, if we considering the payment type for the transaction purpose, we are considering the P99. Okay, so P99, that means out of 100 requests, my 99 transaction should be able to finish within 300 milliseconds. That's what I'm trying to achieve. Whereas if I go with the history endpoint, so for history, what I will do, I will check the payment history, 100 transactions. And again, history is not the critical one that I need to be like have the SLO of 300 milliseconds. So what I would do here is in the query itself, I will increase because for the history, it need to check the historical data like for last 3 months, 6 months, right? So overall response for the history transaction will be high. Based on that, I will change my expression. If you see here, what I'm doing is that I'm checking the latency, which is greater than 0.3, that is 300 milliseconds. So for history, I will prepare the same rule here, but I will increase the overall, what I would say, the milliseconds time. And coming to your point, like on the production environment, how to catch this particular transaction request and response timestamp, right? So that is something we need to configure. The logger that we usually configure in our application. So you might have seen like the response starts with overall HTTP. We will get the response details, and at the end of the response, we will have the complete execution time in milliseconds. In microseconds. Correct. You getting my point, Bhargav?
Yeah, I got it.
So based on that, we can calculate the overall microseconds, and we will be able to set up the latency based on those parameters. Okay, so moving on to the next part. Okay, so now we discussed about the Prometheus YAML file here, right? So you might have seen this node part. Okay, so coming to this Prometheus YAML file, we discussed about the script part and the payments and all. Now, one of the important parameter here is node exporter. So when it comes to the production like configuration, the node exporter is nothing but like it is nothing but it will help your servers to to export the server configurations like the CPU, memory, disk metrics. So from the whatever the servers that you have in your application, let's say you have standalone Linux servers on your application, right? So to export all the matrices from your servers, the node exporter will usually we need to install the node exporter agent on your applications, and from there the node exporter values will be pulled by the Prometheus, and the same we can use it for the matrix calculations. Okay. Now, see, now we have seen that. Okay, so
sorry to one doubt, node exporter agent will be installed in the servers, you're saying, correct?
yes, that's right. Yeah.
Okay. From that servers, the logs will be forwarded to the Prometheus server.
Correct. It will not. It will be like forwarded to the Prometheus. Correct. That's right.
Okay, got it.
And see, now the problem here is if we have a single server, then okay, you are exposing a target, and eventually your Prometheus will pull that from the. Okay, I will show that diagram here. Okay, so now here it comes the exporter part that we are discussing here. Correct. So if you have a single Linux server, what you will do, you will configure the exporter, node exporter here, and you will expose that to the Prometheus server. Similarly, similar to what were the configuration that we have done to expose our endpoints. But when it comes to the production like scenarios where you will have the thousands of servers, right? So we won't be able to expose one by one servers for your to expose it to the Prometheus server. For a single Linux, that is fine. But let's say your application is running on thousands of microservers, and you need to fetch the metrics for those all servers. So in such cases, usually we have this service discovery part. Now the Kubernetes has a built-in feature like whenever there is a kind of you deploy any new features or you deploy any new changes and all, the Prometheus servers will automatically discover the latest pod, and it will pull. It will discover the new targets, and it will pull the information from the Kubernetes cluster. Okay, so I have one example here. One of the script configuration that we have. I will show that as well. Let me see that. Yeah. Okay. So this is similar to the example that we have discussed. For example, let's say for your application, if there are thousands of EC2 instances are running, okay, and you need to capture the metrics for all your EC2 instances. So the first thing is you will have to, the first way is like either you configure the node exporter on all the instances and expose one by one. And for that one, the AWS has the feature like with the AWS configuration, this is a similar configuration, service discovery configuration. Instead of capturing all the servers one by one, we can simply configure this script config. Okay, and this service discovery will go through this configuration will help, like this is the service discovery configuration, and Prometheus servers will scrape in every 15 seconds, and it will check with this parameter basically configs. The config that we have configured, the role that we have defined here, right? So if you see the role here, we are checking for the nodes, Kubernetes nodes. Okay, so every 15 seconds, our Prometheus server will scrape for all the nodes, and it will try to get all the metrics from the nodes. Similarly, we have to configure for the pods. Okay, so we will have this configuration into upcoming Kubernetes session. We'll look into that part, but just wanted to give the heads up how it works on the production environment. Okay, as of now, you can just wanted to give how it works on the production, but yeah, we will deep dive into in the upcoming sessions. Okay, and okay, this is the sample payments app that we have created. So just like to give the walkthrough what exactly this Python script is doing. So if you see, we are, as we know today, like mostly we are trying to check the overall request flow and the overall application health, request and response health. So we will see, we will try to see if what happens when there is a overall if the SLO get breached. If we see more than 0.01% of the error rate, what happens? We will be able to identify when the latency is increased. So if you see, we have created a Python script here, and if you scroll down, if you see here, we have when we start the instance, it will start creating the instances. It will start creating the request. It's not any creating any new instance, whereas it is just creating a fake request and response samples. Okay, so from this app we are just generating the traffic, and from the Prometheus side we are so if you see the Prometheus YAML file, the Prometheus server has connected to our payment app with the 8080 port. Okay, this is how our Prometheus server is connecting to 8080 port. Similarly, whenever you have any applications, your production servers or any new applications, you need to define that in the Prometheus YAML file. Okay. Now we have one last file here, Grafana one. So in Grafana file, what we are doing is we are just defining the data source. Okay, in the data source, what we have done, when we start building creating the dashboard or starting visualizing, creating the visualizations, Grafana requires a data source. So for example, right now we are using the Prometheus server. Similarly, we have this elk, right? We discussed about the Zabbix yesterday, and we have this Loki, correct? So these are the data sources. So for now, today we are mostly focusing on the Prometheus part. So if you have seen here, like we are defining the data source as a Prometheus, and the Prometheus port has been exposed with 9090 port, and we are connecting the Prometheus by defining this data source. Okay, so if you see this architecture here, from our Grafana, we are connecting to Prometheus servers using 9090 port, and it is purely used for our visualization part.
Santosh, how the authentication happens between the Prometheus and Grafana servers?
Which one? This authentication part you are saying here?
Yes. You mean how Grafana recognizes the exact? We mentioned the data source as the URL in the Grafana, but
Correct.
Still how it trusts the entity.
See, for this one, this configuration, since it is a purely local configurations, okay, I mean, it does not require any kind of authentication part, but when it comes to the production configuration, it requires the keys, authentication keys that we need to enter.
Okay.
Yeah, but since it is, see, there are when we are configuring it in the local setup, it will not have no need of this one. Similarly, when we configure the Grafana alerting part, let's say you have to test the alerting if you get a proper email alerts or calls whenever there is an issue. So for local environment, we do not have this SMTP configuration, right? So we have to just like see if really if my alert is getting triggered or not. The only part will remain is you will get the call out or you will get the email alert or not. So that can be achieved on the production environment, but on local environment, at least you will be able to see if your alert is triggering or not.
Yeah, got it, Santosh.
Okay. So, okay, so that's all. Like we have this SRE lab, like the files that we have configured so far, and this is how the architecture looks like. Okay. So today what we will be doing is our application, this payment app will be, we have this container open, and our Prometheus servers will keep on pulling the scraping the logs in every 15 seconds, and we will see how that looks like. And we will I will be sharing the commands that we need to, what we will do, we'll have the chaos run as well. So whatever the transactions as of now our app is throwing, we will try to increase the error rate. We will try to increase the latency when once we start the chaos run. Okay. So I will be sharing that those local commands as well. But before that, let's start with our overall running the Docker desktop container, and let's start building the app first, and let's start opening the app. So to start with, uh, we have to perform the same operation. Let's start with the Docker build first. For me, it is already, I checked my Docker instance few minutes back, so it's running already. So I request everyone to start their Docker container and start the Docker build. Let me ping that comment over here. Okay, Shrikant, looks like you missed yesterday's session, right? Okay, no worries. So what I will do, I will reshare the SRE lab zip file that we worked on yesterday. And the first thing is, like, you can, at present, you can download this Docker desktop, okay? And
Yeah,
unzip this SRE lab. I will share this lab again with you in our call. And
yeah. If you don't mind, can I share my screen, or it will take time? So, or else I will take help from any other person later point in time, and then.
no worries, no worries. Let me do one thing. Let me share the Docker desktop download URL here. Okay. Since
Okay.
everyone is right now started building their app, so in the meanwhile you can download the Docker desktop. Okay.
Yeah, actually, yeah. Yeah, Navya gave me that to download the file, but it is asking me extensions while downloading.
The Docker desktop you're asking, or like what
Yeah.
is the issue?
Yeah. When I was trying to download, it is asking me some extensions and all. So, okay, you can proceed with class. I will.
Yeah.
Yeah. Sorry
Sure. In
to
the meanwhile,
interrupt.
let me see.
Yeah. I don't want. Yeah, to disturb.
Team, please confirm in the cons in the chat box once you are uh, done with building the instances. Once your containers are up. Okay. Shrikant, just I have pasted the Docker installation. Hope you have the Windows machine, so you can download the Docker desktop from here.
Yeah, I'm trying my best. Yeah.
Okay, okay. And team, please check if all the instances are running fine. If you are seeing any issues, should be all the instances should be running. So you can check that with the Docker space PS. Okay. Thanks, Ankit. I hope containers are running for everyone. So I am proceeding with the next step. So we will check if we are able to open all the metrics and Prometheus and Grafana endpoints. Okay. Let's check that. So as you can see here, I am checking the metrics here, correct? So we have opened our payment app with 8080 port. So when we do this 8080 metrics, we should be able to see uh, the overall request and created from this app. Okay. So let me think that as well. In the meanwhile, let me share all the commands, localhost commands. Okay. Also, please try to access the Prometheus instance with localhost 9090 and check if all the targets are up with this command. Lab reference. Okay, thanks, Krishna. So I have just shared the lab reference, the commands that we will be using. So you can download it from here. Let me know once you are able to download and able to access all the URLs. So Prometheus targets, we will be checking this with localhost 9090. So first command, we need to check if our all instances are up or not. We can check that with the up command, and even we can check the same on the targets. So if you can see here, we have these containers running, payments app, Prometheus, and node exporter. So when you see a value as 1 here, that defines like your target is up and running. When your target is down, you will see a value of 0. Okay.
Santosh, can you share the link of the page that you have open on your screen right now?
Yes, sure. Yeah. I will ping all the localhost URLs over here. Just a minute. I have shared this file right from the transfer app. So from in that we have all these commands. So also we will check if our payment app is accessible or not. Since we opened that with 8080, we will see if it is accessible. Yeah, it is. Also, please check this localhost 8080 if you are able to access our node exporter values. So you should, these values should be keep on changing. They will since we have started the app, we will see the increase in overall traffic, increase in traffic for all the endpoints. So check with the metrics as well, localhost metrics.
I think that is related to local host, right? When your instance run, then only we will be able to open that in our local browser.
No, so see this, what we have done is our payment app, we have opened that payment app with the 8080 port, right? That is the target we have set. So with 8080 metrics, it is pulling the information for this endpoint only, for metrics app only, payment app. When you say the local environment, so by default, it will be 9100. So if you see 9100 metrics, so this is the Docker virtual box that we have, right? So this is the configuration from that metrics. This is nothing but the node exporter. Check for the alerts as well. So we discussed about the alerting part as well, right? So check if you are able to access the alerts. I hope everyone is able to download the file I've shared, lab to reference txt file. In that we have all the URLs, important localhost URLs for Prometheus, Grafana, and payment type as well. Please try to access them one by one. Except the fake node, the fake one is like to capture the matrix values, but that is not able to access. We are not able to configure that. You can ignore that part, but rest all Prometheus, Grafana, and payment tab URL should be working. Let me open that as well. Yeah, I have shared all these URLs with you. Please check it. So once the Prometheus server is up, we should be able to access all these URLs, configuration files, and all. So Krishnan, you asked about the configuration that we can update from the UI part, right? So you can see here Prometheus configuration file. So you can modify from here. You can change the script interval and all. Is everyone done to the steps? Okay. So we'll start with first, we'll start with executing the commands now. Okay, from the same file that I have shared. So we have checked the up instance, and so these are nothing but the request for 5 minutes and all. So okay, let's check one by one. Okay, what exactly this PromQL exactly how they works, and what exactly they mean, like when we say increase and when we calculate the rate. Okay, so we will first see the overall payment request, total request in every 5 minutes. Okay, so that is nothing but we can calculate by using this payment request. So by default, we will get in every 5 minutes. I need to check. So this is how I will get it, but this is the raw sample, right? So we will have to get a proper overall number of payment requests, right? So what we will do, we'll see the overall increasing. So since these transactions are every seconds, we are saying that they are increasing. So we will have the increase rule here, and what we will do, we will add all the transactions that are getting increased every 5 minutes. With that, we will be able to see the overall count. If we refresh, they will keep on increasing. So now in next 14 or 15 seconds, again it will scrape and the value will be increased. So now we will see how many requests are getting failed. Let's check for with the basic our payment pay API, right? We'll check one by one. So check with the pay. We can check with status here. Here I will be checking with 500, or we can check 5 star star or 5 dot dot. And we will be checking that in every 5 minutes. Yeah. Let me ping this query here. So if you can see, everyone, like the overall value for this error is like 0.03, right? So the same value we will have to use it when we have to compare with when we have to calculate the overall error budget. Okay. So now this is like overall 5xx that we are getting. So what we will do, we will compare that with the traffic. You can simply duplicate the same. Now instead of 5xx, we will compare that with overall traffic, right? So we have this query, right, already for the same file. Instead of status, I will check the overall traffic for the same point. So I will simply remove the status 5xx. This should give me the overall traffic for this API, right?
Santosh, can we club two graphs together?
Yes, yes, we will be doing the same in the next query.
Okay.
Okay, it is still firing. Let me see. So it is more than 300 milliseconds. Okay. Now the next query that we will build here is, now if you see in the first query, we have checked the overall rate of the 5xx transactions, and that we are comparing with the overall traffic. Now we will club the both queries over here. Like we'll simply try with dividing with the 5xx transactions by divide, and let's see if that works. Yeah. And what value we are getting here? So if you see the overall execution value that we are getting over here is 0.003, which is less than 0.1%. So this is how like we are checking the overall error rate. Okay. So since the ratio is like less than 0.1%, we will not get any kind of alert over here. Similarly, you can try the same command I have shared the document that we have for the latency. You should be able to see the overall latency value. And we will, once we start with the chaos script, we will see some overall increase in the error rate and all, and which will eventually trigger the alerts. So just to have a proper hands-on practice for this queries, I would like you to, run at least one these commands on your PromQL and see how they are performing, and if you are seeing the same results. I will ping this as well. Correct. Yes, Abhishek. So since 0.1%, so no, this is 0.00433. The vacancy is 0.004. No, we are see the overall error rate is it's not like 0.1001. See the error rate. See, I will show you that part as well. The script that we have configured, right? The alert that we have configured. See, if the errors are more than 0.01, okay, 0.1% here, like we are checking for 0.01, not 0.0001. So when we see it is greater than 0.01, then it will trigger. And the value that we are seeing here is per seconds. Okay, so that's why the value that we are overall observing here is per second. So that's why we are seeing this value. Once we start increasing the overall error rate, you will see it is more than or more than the threshold value, and it will trigger the alert. Okay. But at present, it is less than 0.1. So that's why it is showing a normal trend. In the meanwhile, please open the Grafana instance as well. Let's configure the same dashboard in Grafana. The same steps like we discussed yesterday. Log in with the admin and create a new visualization. So here again, we will select the data source as a Prometheus, right? And we will use the same query that we have used in the PromQL. Click on the code and just copy the same query PromQL query. I hope everyone is working on the same step that I'm doing. We are setting up the same query on Grafana now. Simply the same query that we have tried on the PromQL. We are executing the same on same query on the Grafana. Okay.
Shantosh, actually, I'm not getting this option for, I mean, putting the query after this Kickstart your query.
Okay. So in edit option,
Okay.
you will see two buttons over here, builder and code.
Once.
You have to click on code. By
Okay.
default, it will be builder.
Yeah. It's there now. Thank you very much.
No worries. So
Yeah, now I'm getting the output.
okay. You are getting the result. Yeah, the graph is the graph. Please confirm
Yeah.
if the graph is loading.
Yeah, it's loading for me now.
Perfect. So you can update this graph name as system. Okay. Similarly, so this is nothing but our overall error rate, correct? So we will let me check the rename option. Get the graph here. Yeah, this is fine. Now, similarly, we will create a new same graph for latency part as well. And once we start with the chaos, we will see the overall increase in traffic and alerts and all part. So let's start building for the same latency. Now, let me ping that from query. I already share that in our document, but let me
Santosh, can we have this is for which graph? This is for
okay. So you want me to have a proper
no.
naming
Whatever.
and
No. That's okay. Naming is fine. That is not an issue. I wanted to have correlated graph for total request versus 500.
yes. Okay. So right now the graph that I have created, right? It is for it is a overall error rate. But if you would like to have a proper graphs for each and every query, we can create that as well. What you can
No. Santosh, I totally understood that we can create different graphs for total request for error rate. What I want is we can also have total request and error rate in the same graph, right?
Yes.
Which show total request as a separate graph and 500 requests as a same separate graph in that itself, so that it will be easy to correlate.
Got it. So you want me to display the same overall error as well as the successful calls in the same query?
Yes.
Okay.
We just wanted to know how to do that.
Okay. Let me check that part as well. So here we can add one visualization again. Okay, so you can see here we have this prompt query, correct? So let's check one by one. So first start with the 5xx. That this will give us the overall error rate, correct? I will add that query here. Now let's see if it is loading fine or not. Yes. Now here you would see an option called add query. Chandan, are you following me?
Yes, yes, I'm following you.
Okay, so if you can see here, in the same graph, we are able to visualize the overall transactions and the error rate as
Yeah, got that. Where is that add query?
well. Okay, yeah, you will see it next to the first error, the browser that you add here, right? You will see the first query. Below that, there is an option called add query. You can
Oh,
see
got
here.
it, got it, got it. Yeah.
Yeah. So if you, from here you can add a number of queries and like let's say you have multiple endpoints. So based on that also you can add the queries.
Got it. Yeah, we can proceed. Yeah.
Let me save that as well. So as you can see, we have created two dashboards here. This is nothing but the overall error rate and the alert that we have configured. If we see increase in the error rate, it should trigger an alert, right? And this is the dashboard. We could see the overall transactions and yeah, the errors per seconds. So yeah, we have to modify this if it is not giving the correct value. Let's try with increasing, starting the chaos first. Now for error rate, let's check if we are able to see a proper alerting, if it is triggering, if it is whatever the rules that we have set, if it is firing that alert or not. So how we can do that? We have this chaos or error in place. So let me ping that localhost command over here. Please try accessing this URL. So with this, we are increasing the error rate and hopefully the Prometheus will also pick the same and we will be able to visualize it. Please check that out. Check for last 1 hour. And here you would see a slight increase in overall error rate. We will monitor that for a few minutes. Let's see. And you can simply duplicate one session, Grafana sessions, and click on the alerting part. We have this alerting rules, right? Check if you are seeing any alerts over here. Let me pin this as well. So as you can see here, we are observing that there is an increase in error rate, correct? Overall errors are getting increased. And the error rate has also started spiking up. Now, Abhishek, as you said, like we have configured the alert for 0.1%, right? Once we see that the overall alert has reached 0.1%, we should be getting alert should be triggered, right? So let's check in the alert list if the alert is getting triggered or not. Yeah, it will be real time, Abhishek. Like the script time that we have configured is for 15 seconds, right? So every 15 seconds it will pull. Okay, and based on that, so there is a rule that we have configured over here, right? So if you can see, we are started seeing the alert over here. Okay, now we have configured like for every 2 minutes it will keep on checking, and if it observe that error rate is more than 0.1%, we are observing over here. Please check if you are also observing the same. We are observing the error rate is more than 0.1%, and this alert is getting fired now. I hope it is same result for everyone. Please confirm. Please check in the alert rules, and in alert rules we have configured these rules as we discussed. That we have configured the rules.yaml file, right? We have gone through that YAML file, and where we have set the expression that if the error rate is more than 0.1%, we should be getting the alert. So since if you see in the graph, the error rate has exceeded 0.1%, it has started throwing the error. So this is how something like we need to achieve the error rate. So hope we are able to connect the dots. Last week we discussed about the error rate, correct? We need to make sure our availability of our application should be 99.9%. This is where you need to monitor the 0.1%. Usually in the interview, mostly the interviewer asks this question. When you say that you have configured the 99.9% of the availability, how are you monitoring the 0.1%? So this is how we need to answer, like what kind of alerting or dashboard that you have built, okay, and how is it capturing the overall 0.1%. So far, like if you have any doubts or any queries, please feel free to post in the chat, or you can talk. So we are you can see here the real time we are able to see there is an increase in error rate, and the alert has fired. So alert is triggered. Yep. I hope for everyone the alert is triggered now. Please confirm or give me the thumbs up if you have finished this step, so that we can proceed with the latency part. Excellent.
Santosh, for now, I have pulled all the Grafana, everything, Prometheus, and lab setup and all.
Perfect.
So, no, so I need to run this Grafana, right?
Yes. So I have shared the lab details just a few minutes back. I think Krishna has also shared that. You can start following the commands like from the building the first, like we need to start our containers, right? So you can start from that step. Okay. Once your containers are up, try accessing the URLs we have given in the document. Localhost 9090, 3000, and 8080. So these ports we have opened. You should be able to open these URLs on your browser. Okay. Team, we will take 5 minutes break here, and we'll start with the latency once we are back. Right? Thank you. Okay. I hope everyone has configured this two dashboard for the error rate, and we are getting the alerts getting triggered, correct, in the error alert list. Okay. Now, when we have to configure such kind of alerts on dashboards, like so this is something that you are able to see on the dashboard. But what if we have to get alerted out of office hours? Let's say your application is down at midnight, right? So you should be getting some pager duty alerts, or you should be getting the alerts from the Grafana, right? So you can configure the alerting part as well. So if you can see the alerting option over here, correct? So we have three options over here. First of all, we have to set up the alerting rule, okay? And uh, then we have to add the contact points and the policies, okay? So we will quickly go through one of the example. Like, let's say if I have to configure the alert for this error rate. So let's try to configure it. We will select the Prometheus as a data source. Now, as you can see, we are seeing the error for both payment API slow as well as this error rate 1%, right? So you can refer, if we have created any new dashboard, you can refer your dashboard as well. No, if you have a dashboard for the payment and you're precisely looking for configuring the alert for payment API, so you can select that dashboard over here. Okay. Yeah. So you can configure the alert something like this. So first we need to create a rule, okay? So for like once that rule is triggered, then only similar to like how we are saying the alert for in the alerting rule, right? So similarly, we have to use the same PromQL query over here, and we need to, for now you can remove these condition expressions. We have to set up the evaluation. So at what instance, like sometimes what happens, right, during the low peak hours, we see that overall traffic is not that high, but sometimes like we see let's say there are two transactions, out of which one transaction got failed. So that means like the overall error rate during that time is more than 0.1%, isn't it? So when we have such kind of use cases, we can have this evaluation behavior. So evaluation behavior is nothing but like at what instance, like at what time you have to create. You can create some set of rules, like from this time to particular this window. We can skip the monitoring, or we can mute the alert instead of triggering the false alerts. So you can set such kind of evaluation rules over here. So let me create one folder. Now we will use the same query, PromQL query that we have used. Right. Where is it? Now, if you see, when you run the query, you will get the value over here. Correct. So if it is more than 0.1, ideally it should trigger an alert. So since we have started the chaos run, we are observing the value which is more than 0.5%, and you can trigger the alert from here, and just save the rule and exit. There are some okay. So here, if you see the contact points you have mentioned, we have to provide our contact details over here. So this is how we can configure the alert. Like whenever there is an alert or you need a call out, so you can add, you can have the email alert. You can add your contact number as well. So something like we have this contact point option over here, correct? So from here you can add your contact details. Let's say I have to add my contact number and whatever it is, like whatever the options that you're looking for. Like, so sometimes you can configure the webhook alert as well. So yesterday I was explaining about the war room alert, right? So when we see that the error rate is high, instead of informing individual person, what you can do, you can directly involve the war room. Like the war room will team will have their endpoint. So, okay, so what will happen once you webhook that URL? Let's say you configure a war room URL over here. So when you see that there is an issue with your application, instead of calling out, along with reaching out to you, it will trigger an alert with the command center, and the command center will eventually they will open the war room on your behalf. So let's say if your application is payments, which is a critical one, and if you have to set up a P1 or P2 level severity incident, so you can create a webhook war room URL, and once that alert is getting triggered, it will open the war room on your behalf. So you no need to reach out to the command center team to open the war room and to start triaging the issue. It will automatically invoke their endpoint and it will open the war room. So sometimes I have seen that Grafana alert is so quick, and Datadog alerts like we have configured, they are so quick that they usually open the war room before we get an alert. And the command center team used to call us, okay, we have a alert from the Datadog or Grafana that your application is down. So with this kind of alerting, is if we configure your alerting in such a way, so you are engaging the right person, right team, and if your application is down at any time, you no need to worry that the night as well. If you see any kind of such spikes or issues, your alerting will take care of it. This is nothing but the alert manager. So we have discussed this part in our today's when we started our session, right? So this is the alert manager part over here. If you can see, so alert manager. So we can configure it via alert manager. So if your application has any specific alert manager tool like PagerDuty and all, you can configure from there as well. But even from the Grafana, you can set up the alerting part. So someone asked the question about the alerting, right? When we started the session about the alerting, how can we set up in the Grafana? So this is like this is the process. So first you need to add a alerting rule, then add your contact point of contacts, and yeah, you can engage the respective teams. And once it is done, instead of see, sometimes what happens is it will trigger a false alert as well. So you can check by sending the test notification. From on your behalf, it will send a test notification to the respective teams, and see unsupported protocol, because this SMTP is not supported on our local configuration, so it is not sending any notification. So, but like when we configure this URL and endpoint, it will send the notification to the team. Now we have started this errors, right? We have started the chaos. We need to stop it now, since we are able to validate if our alerting is working fine or not. So simply use the same command. Instead of on, you just have to do it off, so it will stop sending the error messages. You can use the same command. Hope everyone is clear about the alerting part. Team, please confirm. Please give me the thumbs up or any confirmation if you understood the alerting part.
So basically, we will engage either production support or any other lower teams which
Yes.
are on top of us. Then it will, if there anything is down, so there will be a notification with the help of alert. Also, they will receive and they will reach out to us after triaging the steps. If it is not required, they will send out an pager duty alert to our SRE teams if they were not able to resolve. That's so, right?